Hi guys, welcome to my blog. To beat or not to beat. Hope you like the phrase. I find it kind of funny. Today I wanted to go over how to OTA with Arduino bootloader. As part of my home project, my smart home project, which is open source, and I'm gonna link everything in the description. I wanted to update the boards while they are installed inside the walls. I didn't want to take everything apart every time I have to update my code. And I have my own protocol and my own method to do things, so I wanted to have a full control over the OTA process. So I was looking through the web for a lot of options, and I found a couple of interesting ones, and I'm gonna show you them, but I wanted to show you the one that I'm using, which is based on another open source projects. I'm gonna link everything in the description, included the tools needed to do that. So let's get started. So the first thing that I wanted to show you is the My Sensor project, which I didn't use eventually, but you should check it out. They have good solution for everything. They have an application for Windows and Mac that control the process of flashing. They have their own bootloader, and basically their infrastructure to control to make the connected network for whatever you're gonna need. They have a thing that's called node, and nodes can talk to a gateway, and you can flash them remotely. So it's a very nice solution. You should definitely check it out, but it was too high level for me. So after searching for quite some time, I found the OptiBoot open source, which led me to this guy. And he forked the OptiBoot, again changed it a little bit to support over-the-air flashing. But this source was a little bit complicated as well, because it was needed to build with a makefile, and I had some troubles with that, but the basic concept was fine. So it led me to this source, to this guy, which forked these two solutions. This one is the bootloader, and this one is a flasher, which flashes the remote station using a local station connected to the computer, which I'm going to show you in a second. So he forked this solution and this solution, and this is the result. And eventually I used his code with a little bit of tweaking for debugging and a couple of changes for the hardware, which I'm going to show you. Okay, so let's go over it. The first thing, you can't see it here, but the reason it's easier to work with this source file is because you can just load it into your Arduino IDE. Okay, this is the flash. This is the bootloader, which I haven't changed except from some LED flashing for debug to make sure that everything is working. And you don't need everything here. I'm going to put in you can check out the blog later for the low resolution details to see how everything needs to be done. But basically you compile this project and you flash it, and you flash this bootloader on your Arduino on the remote station, where you need to flash a new sketch remotely. For those of you that don't know, the bootloader is the first program that runs once the microcontroller is loading, and after the bootloader is finished, it's calling your sketch, and then your sketch is starting to work, and it works in a loop. And when you're connected via USB to the computer and you want to flash something from the Arduino IDE, what happens is that the USB resets the board, and then it's getting into a bootloader, and the bootloader is waiting for a couple of fractions to see if someone is talking to him with a known protocol over the USB, over the serial actually, and he's gonna take the bytes that are coming from the serial and override the sketch that used to be there with the new sketches coming through the USB, through the serial. So what we want to do is not listen over the serial, the UART. We want to tell it to wait for the packets that are coming from a remote device, from the antenna. In my case is the nrf24, which I'm using, which is an extremely simple wireless connection. So basically the local station is going to forward the packets instead through the UART, going to forward everything through the RF24, and the bootloader here on the remote station is going to capture everything and flash it to override the local sketch. Okay. So let's see the flasher program, which is the hard part, and I'm going to explain why in a second. The flasher program is the one that you're going to burn like any sketch. You see it's a regular Arduino sketch, and you're going to burn it. And this is, again, this is why I use this solution, because it's based on Arduino. You don't compile it with Makefile, you just compile it with the Arduino IDE, which is a nice thing he did, and he also updated here on the pins and everything works perfect. And once you flashed your local station with this program, the goal is that your computer is now trying to upload the sketch over here, but because of a hardware tweak that we're going to do, it will not be able to flash the station. Instead, this station will capture all the bytes. The computer is thinking that it's flashing this station, but this station is not in a bootloader state. It's just listening over USB, gonna capture the packets and push everything to the SPI, which is connected in our case to the RF24. And this guy is gonna forward everything to our remote station that has a bootloader and gonna flash its local sketch. Okay, imagine it's drawing here. Okay, so how I'm gonna link everything in the description to how to connect everything and which pins and everything, but the important thing here is to understand the concept and to see the hardware tweaks. So this is the local station, and as you can see, you have here the Arduino, and the Arduino is connected to this RF24, and the most important thing here is this capacitor. Okay, I'm gonna link in the description the how much microfarad this capacitor and everything. I think it's 47 microfarad. But the thing is that once you connect your Arduino IDE to an Arduino and you want to flash it, so the program is sending over USB here a signal that resets the board and loading it to a bootloader state, and then the computer sends via UART the packets, and the bootloader here flashes its own program. But we want to avoid it. We want this station to forward everything from this guy to the remote station. Okay? So in order to prevent the reset, the USB reset that the IDE is doing to this guy, we have this capacitor. This capacitor is connected over here and here between the reset pin and the ground. And because of that, when the computer is trying to reset this guy, it fails, but the computer still thinks it's burning this station, and this sketch over here is going to capture everything as if it was burning itself, and instead of burning itself, it's going to forward everything to the remote station. Okay, so this little guy is doing everything. This LED is just for debugging, so you will know what's happening, because you're going to see in the code that it's gonna try a couple of times before it's gonna quit, because maybe the other station is not in bootloader state. They have a protocol to sync the burning process. So there is a loop, and you're gonna send the first packet that telling the other station to reset and go inside the bootloader, and then the bootloader on the other side is gonna wait for a couple of seconds for the packets to arrive. So this guy is gonna help you for the debugging process, and whenever it's trying to send something to the remote station, it's gonna flash. And once it's failed, it's gonna flash in a different way. You have to be careful with the code that's flashing it, because if it's in the wrong place, it's gonna fail the OTA process, because the accuracy of timing is very difficult, especially when you go over the air and there are some packets there that are missing. If you're gonna change the timing, it's gonna be crucial and gonna affect the process. So you can check out my code, which works, and maybe even tweak it a little bit to get a better performance. This guy here is just when I want to update this station locally and avoid the capacitor, and maybe I have updated the LED debugging thing here, so I want to flash this local station instead of the remote one. So I'm just pressing here, and it overrides the capacitor, and you can flash this program. So basically what you're going to do is go to the Arduino IDE, press on the play button, press here, and it will go to regular flashing state. Another thing to note is this is an example for a station that I'm using for the shades in my living room. This is the power supply that I'm using. I'm going to link it in the description. It's very convenient, small, and I'm doing the job very good. And this is the nrf24l and my Nano with a bootloader on it, with this modified bootloader. By the way, to burn the bootloader, I'm going to show you, you're going to need to use these pins with a AVR ISP, tiny ISP, USB from the computer to these pins to burn the bootloader, and you can use it also to burn sketches instead of the USB. And this capacitor is mounted over the RF to make the power supply for the RF to be more stable, so you won't lose packets or have some noises or stuff like this every time the Arduino is taking more power or something like that. Okay, so what you're going to need to burn. First you will need an AVR ISP programmer for bootloader, okay, because if the process of burning a bootloader is a bit different from loading a sketch. You will need to connect to these pins as I showed you here. You will have a cable for that, and the other side is the computer, and you're going to use a program that is called AVR Dude, and AVR Dude is just a tool set from AVR where you can do some stuff to the Arduino. You can change its fuses, you can upload a sketch, you can burn a bootloader and other stuff. We won't go into too much details, but I want to show you how to use it and where to get it from. Okay, so this is the AVR programmer for Arduino. This tool is what we're going to use to burn our customized bootloader. You can get it here on AliExpress or whatever works for you. This one worked perfect for me. You just connect this side to the computer, and this side, this cable to the Arduino over the header pins that I showed you earlier on the Arduino. From here to the Arduino, it's going to supply power to it and everything. It's going to run. And it's almost the same as the regular USB connection that you're used to, except the commands are a little bit different. So the IDE, there are probably a couple ways to do it with the Arduino IDE, but I'm using the AVR Dude command that we're gonna go through and see the commands. And this utility is just gonna burn everything. Under the hood, the IDE, the Arduino IDE does the same things. It just and it has an option to burn the bootloader, but the process there is a little bit more complicated, and it depends on the configurations board that you have. So I'm just doing it manually. I think it's easier. Maybe I'll do a blog post about the bootloader configurations, and for those of you that want it to be integrated into your RD. Let me know in the descriptions and in the comments below if you would like to see such a video. Okay, this link over here is by Lady Ada, which if you're not familiar with her, you should definitely check her blog post and her YouTube channel. They're doing some very cool stuff, and they have a lot of open source and great blogging articles about very cool stuff. If you're learning Arduino, you should definitely check it out. This site is just a tutorial about how to use AVR and how to install it. You have everything here that you need to install it on your computer, and once you have it installed, we're just going to use a couple of commands for this utility to burn our OTA station. Okay, the simple couple of commands which took a lot of time to discover, especially because of this thing. The thing that happened to me is every time I wanted to flash the remote station, I flashed this station instead, because I was not aware that it's resetting it and getting it into bootloader. So every time I tried it, it failed, and I thought it's the AVR commands, but eventually I found out it's not the AVR command, but it's actually the hardware issue. So mine is installed here on my computer, and we're going to need two commands. There are a couple of things to know about this command. First of all, this is the tool, its configuration, baud rate, type of programmer. So we are using USB Tiny, which I showed you earlier. The type of microcontroller that we are burning. In my case, it's the Nano, so it's at Mega 328. We need to tweak the fuses. We need to use this command and this command in order to make it work, or else it won't work. Okay, it took me a lot of time to figure it out. I'm not sure exactly what it's doing, but without the DA here, it will not work for you. So this is the first command. You just copy paste it, and it getting the board ready for bootloading flashing. Okay, it opens up for writing and stuff like this, and once you did this successfully, you can burn your own hex file. So if you compile your OptiBoot or using mine or other bootloader, modified bootloader, and you wanna burn it on this station, for example, so you connect the USB from the computer and the AVR programmer here. You will see it's going to supply power to it, so you're going to see it on and working. And once it's on and working, you did this first command and then this command. So this command, again, it's the baud rate and USB Tiny and the type of microcontroller, and then we're going to use the flash command. Okay, we tweaked the fuse before, now we're going to use the flash command, and it's going to flash this hex file, okay, over to this station locally, and then it's going to lock it back. So after these two commands, you're all good to go, and you have a tweaked bootloader. Now my bootloader is built with without a watchdog. A watchdog is a trick they did over there to reset the microcontroller every couple of seconds, just so you will be in bootloader state and try to program itself remotely. Okay, I'm gonna get the packets from the RF24 and flash the sketch. But I didn't want my station to restart all the time, because I wanted to be ready to get commands from my server, my home automation server. So I disabled this one, and I have a thing on my OTA that getting a reset command is going into bootloader. It's just a piece of code doing the same calling the same function that the bootloader has here, and it's going into reset state, and the bootloader is loading and waiting for the packets. Another small thing to be aware of is once you change the bootloader to use the nrf24 library instead of the UART, once your sketch is up and running and it also wants to use the nrf24, you will have to have the same base code for both stations, for the sketch and the bootloader actually, that I'm using, that both sketches, both code parts are using the same hardware. You will have to use the same code. And why is that? This guy has a little of registers and stuff that the bootloader is configuring to send or get the packets. So if the sketch is using a different configuration for this guy, then once it's tweaked him, this guy will not be able to flash or to use it from the original program. So the thing that I did is to use the same nrf24 library, which is MIRF, the default one, and I tweaked it a little bit just so we'll have the same code. I will link it in the description as well, the code that I'm using, and I'm using it as a common project for everyone, and everyone are compiling with the same source and has the same commands. This way the register is configured always the same way, and the bootloader and the sketcher can use the same library for RF communication. Okay, so thank you guys. I hope you like it and it's gonna help you. Feel free to ask anything that you want on the description, in the comments below, or on my blog. I'm gonna keep it coming for this series of DIY smart home or home automation, and I'm gonna put videos and articles on my blog about how to do it, how to use, what the architecture that I use, what I'm using, for example, the Pi, Raspberry Pi as my home server, and a couple of other cool tricks that I learned over the way to communicate between the stations, and the tools that I'm using, everything. So hope you enjoy it, and please subscribe, and I hope to see you next time.